Welcome students to the chapter 3 of 10th class, metals and non-metals. Let us study the properties of metals, the physical properties. Physical properties means the properties that you can see physically from. So almost all the metals are in solid state except mercury, which is found in liquid state. You can see mercury in a thermometer. Metals are hard. Most of the metals are hard. But there are exceptions that there are soft metals like potassium, sodium, lithium. They are those type of metals that can be easily cut with the help of knife. They have very low densities and very low melting point, the soft metals. But the hard metals, they have got high melting point. They have high densities, means the weight is very high. They are lustrous in nature. They are shining. You can see gold, silver. They're so shining. Platinum. Metals are malleable in nature. That means they can be hammered and beaten into thin sheets. I think you might have seen on the sweets, silver that is placed. You eat that silver. That is, silver is hammered so beaten. It is to make a thin sheet that you can easily eat. It is put on many sweets. Metals are ductile in nature. Ductile means they can be made into thin wires. For example, 1 gram of gold can make a wire that is as long as 2 kilometers. As I told you, they've got high melting point, but again, they have exceptions like gallium and cesium. They've got low melting point. Gallium can be easily put on hand, and at our body temperature, it will melt. Metals have high boiling point. Then metals are good conductor of heat. For example, silver and copper. They are poor conductors, metals, exceptions are there. They are lead and mercury. You should know the exceptions. Metals are good conductor of electricity, and the best conductor is a silver, and then comes the copper. So in this topic, you have to learn all the points with exceptions. So here you can see lithium, sodium, potassium. They're very reactive metal. Reactivity metals means as soon as they're exposed to air, they'll react with air. As soon as it is kept in water, they'll react with water. See, in air, how sodium is reacting. And see in water, how sodium is reacting. They're very reactive metals. They have to be kept in kerosene. So this is lithium, very reactive. Then comes the sodium, then comes the potassium. Okay. So first it is sodium and then it is potassium if you want to follow the order. This is a gallium, as I told you. At body temperature, human body temperature, it will melt. This is poisonous, therefore you cannot put it on hand. So you can see little normal body temperature also, if you bring that cesium metal, it will easily melt. Mercury is a metal that is found in a liquid state. Let us study about the physical properties of nonmetals. And after learning both the physical properties of metals and nonmetals, you'll have to write the differences on your own. Okay. So nonmetals are found in all the 3 states, the solid state, the liquid state, and the gaseous state. Examples of solid states are the carbon, sulfur, phosphorus. Liquid state is bromine. And gaseous state, oxygen, hydrogen, nitrogen, etc. Nonmetals are mostly soft in nature. Exception is there of diamond. It is the hardest material. We got a Mohs scale, and on Mohs scales is from 1 to 10, and diamonds ranking comes in 10. It is hardest. It is used for cutting many of the materials. They are not lustrous in nature. They're not at all shining, except iodine, which is in shining. They're not malleable, that is, they cannot be made into sheets. They're not ductile, means they cannot be made into thin wires. They have low melting points. They have low boiling points. They're bad conductor of heat. They are bad conductor of electricity, except graphite. Graphite, that it is found in pencil. You can make a circuit and connect the circuit with the help of a graphite in between. The current will flow, indicating that it is a good conductor. So graphite is a non-metal, but it is a good conductor of electricity. So in exams, they can ask you that, how will you know that graphite is a non-metal, but it is a good conductor? So you have to draw a full circuit and the conducting wire is copper. In between, cut the two conducting wires and place a pencil which should be sharpened on both the ends. That is, the graphite should be exposed, attached with it, and it is attached to a cell. If the current passes, that is, the bulb is glowing, it is a good conductor. Metals are not sonorous, means they don't give a ringing sound. Like metals, they are sonorous in nature. Whenever a bell rings, you can see that sound is called as sonorous. So non-metals are not sonorous in nature. So here you can see iodine. Iodine is a non-metal, but it is lustrous. This is an exception. Bromine is a non-metal, but it is found in a liquid state. You have to learn all these exceptions. Non-metals that are found in solid state. There are many non-metals that are found in solid state. Sulfur. Whenever there is volcanic eruptions or in a place where there are hot springs, you'll always find sulfur over there. Carbon. There are many different forms of carbon. They are crystalline and they are non-crystalline form of carbons. This form of carbon, because it is found in different states, one is a coal and one is a diamond. Both have got chemical constituent of C. Here it is CeSe. That means they both are allotropes of each other. Similarly, phosphorus. We have got white phosphorus, a red phosphorus, a black phosphorus. They all are allotropes of each other. Let the constituent of all of them is P, that is phosphorus. So what is allotropy? The existence of two or more different physical form of a chemical element. The chemical element is one, but it is found in different physical forms. It is called as allotropy. For example, let us study the allotropes of carbon. Carbon has got two forms. One is a crystalline and one is amorphous. Amorphous means it is not a crystalline form. Crystalline form means a perfect crystal is found like a diamond and a graphite. And non-crystalline form, you have got coal, got a charcoal and a lampblack. Charcoal I've already taught you in the chapter 14, my last video. So this is lampblack. How you'll get a lampblack? There's a candle and you can see the flames, that sooty flames that come out, the black flames. If that is collected, then that is called as lampblack. The kajal that is put in eyes since many generations is also a lampblack. You can take a cotton and put it in ghee and then burn that cotton and put a small layer above it. The black color that is obtained is called as lampblack, and it is perfect black. You can put it in your eyes as in the form of kajal. Now, let us study the chemical properties of metal, and we will be studying over here many reactions. The first reaction is reaction of metals with oxygen. Not all the metals react with oxygen at the same speed. For example, we just learned that these are metals, and they are not kept in air. Why? They react so vigorously. So reaction of more reactive metal, as soon as they were exposed to air, they'll react. You can see copper. You have got copper vessels also. You just put it. It is not going to react with oxygen. You have to heat it. When copper is heated at a certain temperature, you'll get black color copper oxide. So here no heating is required. So at different temperatures and depending upon the reactivities of the metal reacts with oxygen. So copper has to be heated so that it can combine with copper and it forms copper oxide. You can see the utensils, they become black because the copper oxide layer is formed over here. Similarly, aluminium, it has to be heated to form aluminium oxide. But see, sodium, it is not needed to be heated. Just exposes to the atmosphere, it will react with oxygen to form sodium oxide. It will react with water to form sodium hydroxide. Similar with the potassium, it will react with oxygen to form potassium oxide. And potassium oxide, then if you put it in water, it will form a base KOH, that is potassium hydroxide. They are very reactive metals, and that is why they are kept in kerosis. There are some amphoteric metals also. Amphoteric metals means those metals that can behave with an acid also and with a base also. They show both acidic and a basic properties. For example, aluminum oxide. This aluminum oxide can react with acid also. It can react with base also. With an acid, it will behave like a base, and with the base, it can behave like an acid. And the reaction is salt plus water. So water is formed. This is acid, this is base. So the aluminum chloride is formed. Here water is formed. So what else? Sodium aluminate. It is a complex salt. So different metals reactivity with oxygen is different. Potassium and sodium will react very vigorously with oxygen and they'll catch fire. Therefore, they're stored in kerosene. You might have seen magnesium in the, there are magnesium metals that it put in Taramandal when during the Diwali season festivals, you bring that Taramandal, and whenever you burn it, there's a white flame that comes out. It is because some metals like magnesium are put in it. So magnesium always burns with a bright light to form magnesium oxide. Iron is heated. It glows brightly. If you have seen iron heating, it will give red light. When copper is heated, it will not burn. It will not give any light. See, these are giving flames. Sodium, potassium is giving a flame. Magnesium is burning. It is burning. Iron, it is glowing red. And copper is heated. It will not give any flame, but it will burn and it will form a black coating that is called as copper oxide. Silver and gold, they do not react with oxygen. You've got many jewelries which are made up of least reactive metals like the silver, gold, and platinum. They are called as noble metals also because they don't react with oxygen, even at a very high temperature. So metals like magnesium, aluminium, zinc, lead, they form an oxide layer over it to prevent further oxidation. That is, they are self-protecting. So you can see aluminium, a layer of it will react with oxygen and form an aluminum oxide. Once an aluminum oxide layer is formed, the inner aluminum will be preserved. That is, it is called as self-protecting. The inner layers will be protected. If you remove that oxide layer, again the aluminum layer will be exposed. Again that layer will convert into aluminum oxide and below layer will be protected. Now, the reaction of metals with water. As we learned again, sodium and potassium, they vigorously react with water and they form NaOH, that is sodium hydroxide, and potassium hydroxide with the liberation of hydrogen gas. Calcium, they also react with water, and during this fumes, since it is lighter, you can see they comes up along with the hydrogen gas on the surface and forms a white layer of calcium on the surface. Aluminium and iron, they do not react with cold water. For them, the water has to be heated, and the heated water should be in the form of steam. So the aluminium and iron, they'll react with steam. Here I should be putting gaseous, G. These are liquid. So here aluminium and iron has to be definitely be in the form of steam. So aluminum and iron in presence of steam will react. They're not going to react with cold water or a hot water, only with a gaseous state of water, that is steam, and it will give rise to aluminum oxide and iron oxide along with the formation of hydrogen gas. So here you can see OH group is formed, and with steam, oxide group is come. Many times in exams, this whole topic is asked. So you'll have to learn reaction of metals with water. The third one is a displacement reaction. We have already studied this in the chapter 1. What is displacement reaction? A more reactive metal will always displace a less reactive metal. So here, if you see, magnesium is going to displace copper because magnesium is more reactive. Iron is going to displace copper. Therefore, iron is more reactive. Reverse if I put copper over here and MgSO4 over here, the reaction is never going to take place. So you'll have to be very careful when in the exams, if they put copper plus MgSO4, you'll have to learn the reactivity series and write the answer. Yes, that reaction is not going to take place. But yeah, this reaction is going to take place, right? Because magnesium is a more reactive metal and it is going to displace copper. Here you can see magnesium is gray in color. The copper sulfate solution is bluish in color. Because of the reaction taking place over here, what is going to happen? The magnesium sulfate solution is formed. The magnesium sulfate solution is colorless. See, copper sulfate is blue in color. The magnesium metal was grayish in color. And what happened? It has changed to copper. Now copper metal is formed. Copper metal is copperish in color, that is reddish in color. So this is how the reaction you have to explain whenever a displacement reaction is asked. That a blue color copper sulfate reaction, when gray color magnesium ribbon is put inside it, the reaction takes place, and what happens? The blue colored solution changes into colorless solution of magnesium sulfate along with the formation of copper that is red in color. Similarly, things happens with the zinc and copper. Zinc is more reactive, so definitely the reaction is going to take place. The blue color copper solution, gray color zinc is put in it. What will happen? A colorless solution is formed along with the formation of copper that is red. Here it is, you see blackish, but it is red. If you clearly see when actually the experiment is taking place, it is reddish, dark reddish in color. Now the third one is iron. Yes, iron is also more reactive than copper. Therefore, definitely it is going to displace copper over here. And see what happens. This is a copper sulfate solution that is blue in color. Inside an iron nail that is gray color is put in it. The displacement reaction will take place, and the blue color solution will change into green color solution of iron sulfate along with the formation of copper that is red in color. Here in the 10th standard level, you'll have to learn color solutions. Which color solution you have to learn? Copper sulfate. Yes, it is blue in color. Then you'll have to learn iron sulfate, FeSO4. It is green in color. Except that all the sulfates are going to be colorless. So you have to learn only FeSO4 green, CuSO4 blue. So CuSO4 blue, MgSO4 colorless. CuSO4 blue, ZnSO4 colorless. CuSO4 blue, FeSO4 green in color. Okay, so please remember this while writing. Activity-based questions are asked. You'll have to remember these colors. Based on all these reactions of metals with oxygen, metals with water, metals with acids, metals with base, a reactivity series was formed later on. And it was found out that potassium is the most reactive metal over here, and gold is the least reactive metal. Remember, this blue color carbon and hydrogen are added, they are non-metals. So this is a reactivity series going starting right from potassium to gold. Okay. Now here I would like to add, above carbon, that is from potassium to aluminium, they are the most reactive metal. Between carbon and hydrogen, whichever metal's name will come, they are middle order reactive. And after hydrogen, the copper to gold, they are the least reactive metal. That means least reactive means they don't have great affinity to oxygen or sulfide or carbonates. Maybe if they are found in with attached with oxygen, like mercury, HgO, mercury oxide, give little amount of heat, oxygen will be removed. It does not have a tendency to hold oxygen, doesn't have a tendency to hold a water. It does not have a tendency to react much. So they are found either in the native state or in the combined state. They are very easy. It is very easy to remove the oxides from them. Middle order reactive, they are more reactive than the least reactive metal. So you'll have to give little amount of heat to remove the oxygen, more than this. Or else you can take a more reactive metal to displace it, like we have studied in the displacement reaction. And what about the most reactive metal? They have the great affinity with oxygen. We cannot remove the oxygen by just heating. Here you remove the oxygen by little heat, here with more heat, or by the displacement reaction you have removed the oxygen, or you can say the reduction reaction, we will say over here. Reduction means removal of oxygen. Okay, so by reduction reaction you have removed the oxygen over here. And here what you will say, the oxygen is quite attached to it. No reduction reaction or none of the heating will make the oxygen remove from these more reactive metals. Then what to do? A current has to be given. So we follow the method of electrolysis. Okay, so here what happens? By electrolysis, the most reactive metal have to be reacted because they've got great affinity with oxygen. Therefore, they're considered as more reactive. In the middle order reactive metals, what happens? We can use a reduction method by taking a more reactive metal or by heating, either two. and the third is just simple amount of heat you give and oxygen will be removed. That is how we have calculated the reactivity series of metals, because metals affinity with oxygens, acid, bases, water, how the tendency is, how fast they react with them. And after this, a reactivity series has been made. You have to learn this by heart. Now, how do metals and non-metals react? So metals have a tendency to lose electron and become positive ions. So here there is a metal, that is sodium. What is the atomic number? It is 11. What is the electronic configuration? 281. 1 means it is not following a stable octet rule. Therefore, it will give away 1. That is 28. It is giving away 1. So this is plus 1 electron it is giving. And since it is giving away electron, the number of protons are more than the number of electrons. That is, the positives are more than the negatives. And how much more? 1. So plus 1. Similarly with the magnesium. Magnesium, the atomic number is 12. The electronic configuration is 282. It is not following a stable octet rule. Therefore, it will give away 2. So see, 2. So plus 2 electron it is written. It has got 2 protons more because it has lost 2 electrons, and therefore it is written 2 positive. Similarly, the non-metals, they have a tendency to gain electrons and become negative ions, and therefore they are called as electronegative elements. Let us take the example of chlorine and oxygen. Chlorine, the atomic number is 17. The electronic configuration is 287. It is not following a stable octet rule. It will take in 1 electron. That 28 become 88. That means the number of electron is more than the number of protons. How many? 1. Therefore it is minus 1. Same thing is there of the oxygen. The atomic number is 8. The electronic configuration is 26. Now, it is not following a stable octet rule. What will it do? It will accept 2 electrons. That is 2, 8. And therefore, the number of electrons are 2 more than the protons, and therefore it is 2 negative. So remember, when we are talking about this, you should know the atomic number. That is, if I'm talking about chlorine, it is 17. The configuration is 287. 7 is the valence electron. Therefore, valency will be 1. That also you can calculate and talk. Okay. So how a sodium chloride molecule is formed? Because a metal have a tendency to give away electron, and a non-metal has a tendency to gain electron. So see, the valence electron of sodium is 1. See, number of atomic numbers 11. The electron configuration is 281. 1 is considered as a valence electron. Similarly, we'll talk about chlorine. Atomic number is 17. The configuration is 287. 7 is a valence electron. So it will gain 1 electron from sodium and become negative ion. So sodium is going to give away 1 electron and become sodium positive, and chlorine is going to gain 1 electron and become Cl negative. So we can show it like this. Sodium is having 1 valence electron. Chlorine has got 7 valence electron. 1, 2, 3, 4, 5, 6, 7. This 1 electron from sodium will be transferred to chlorine. Yes, it is transferred to chlorine. That is why it has become positive over here. And that is why it has gained 1 electron to complete the octet rule. And that is why it has become negative. And that is how you're getting NaCl. Okay. Similarly, we'll be talking about magnesium chloride. Magnesium over here, you can see it has just moved on this side. So how many valence electrons are there? 2. Chlorine has got 7 valence electron. Another chlorine has got 7 electrons, because magnesium, 1 chlorine can accept only 1 electron. That is why we have kept 2 chlorines. Each chlorine will be accepting the 2 valence electrons of magnesium. So 1 will go over here, 1 electron will go over here. So here you can see 1 from here, 1 from here. Since it has given 2 away, 2 electrons. It is called 2 positive. This has taken 1 electron, therefore 1 negative. This has also taken 1 electron chlorine, therefore negative. And therefore the result answer is MgCl2. This is how the formation of magnesium chloride takes place. The formation of magnesium chloride and sodium chloride that we have seen, they are called as ionic compounds. They are also called as electrovalent compounds. They are formed by the transfer of electrons from a metal to a non-metal. So we have studied the formation of sodium chloride and the formation of magnesium chloride, and they are ionic compounds. Let us study the properties of ionic compound. They are transformed by the transfer of electrons. The metal is going to lose electron and the non-metal is going to gain electrons. They are found in crystalline solid. Let us take the example in NaCl, sodium chloride. It is also called as common salt, and I hope you might have all seen the crystals of common salt at home. It is crystalline in nature. Imagine that's NaCl in your hand, that crystal, and now you can, it has got Na and it got Cl. It is crystalline. It has got high melting point. If you melt it, it is not going to melt very easily. It is easily soluble in water, but it is not soluble in organic solvents like petrol, kerosene, etc. When you put salt in a liquid, in a solution of water, so that a solution is made, that is a brine solution, it will conduct electricity. Here that no salt is put, it cannot conduct electricity. It is a pure distilled water. So certain salt or acid or base has to be put in there. We are talking about salts, so we'll talk about salts over here. So it will conduct electricity in the molten state. This is one of the most important topic. Also, you'll have to learn properties of ionic compounds. Some of the examples of ionic compounds. See, calcium chloride crystal. These crystals are used to melt ice and snow. The crystals lower the freezing point of water. Water is not freezed. Water freezing point is 0 degree. If you put calcium chloride, it may go to minus 4 degree also. To minus 4 degree, you can get water. Second is barium chloride. It is used to make fireworks. It produces green colored explosions. Cobalt chloride. They are used to detect moisture. They change color whenever they absorb water. Potassium iodide. They are the tablets that are given to people who are exposed to very high radiations, and also they are used as medicines to people who have got thyroid problem. So they protect thyroid gland from the radiations. Then is the electrolyte. You might have heard whenever there's loss of water from the body, electrolyte is given to the people. The electrolytes are given to children who have lost large amount of ions from their body. This happens when the persons are having vomiting and diarrhea. Let us go to the lithium iodide. They are the batteries and they are very good conductors. So here are examples of some ionic compound. Ionic compound, you can see it as metals and non-metals. Calcium is metal, chloride is non-metal. Barium is metal, chloride is non-metal. Cobalt metal, chloride is non-metal. Metal, potassium, iodide is non-metal. Electrolytes, NaCl, namak, potassium chloride. They're made of many things like that. And lithium iodide. Lithium is a metal, iodide is a non-metal. So ionic compounds are made up of metals and non-metals, where one loses electron and the non-metal gains electron. Occurrence of metals. Metals like the gold, silver, platinum, they're found in free state. I've already told you regarding this. They do not have affinity with oxides, sulfides. They may be found in independent state. You can get gold directly from the earth. You can get silver or platinum directly because they are least reactive. While other metals that are reactive metals, they are found in the form of oxides, carbonates, sulfides, and halides. So what are minerals? They are naturally found inside the earth crust. What is an ore? The metals are found in the oxide form, carbonates form, sulfide form. They all are which are found on the earth and whose extraction is profitable, from which we can get metals. So like iron oxide, we have to remove oxide by certain processes and get iron. So it is an ore. Okay, so iron sulfide. So again, you have to remove sulfur and you can get an ore. So they are ore, that is, they are minerals from which metals can be extracted profitably. And whenever we get an ore, there's large amount of impurities present from in the ore. Whenever extraction is taking place from certain places, it is not that you're getting the whole iron oxide pure from there. It has got large amount of sand and other impurities with them, clay particles, rock particles, sand. So these are called as gangue, and they have to be removed. So we are going to study all these topics in the next few slides. So you know what is an ore? They are metals that can be found in metal oxides or sulfides, carbonates forms, from which extraction is for extraction of which is profitable or economical to us. All this ore is grinded first, crushed first, and then we are increasing the concentration. Increasing the concentration means removing the sand particles, clay particles, the pebbles and rocks, and all those particles which are not required. Iron oxide with the clay, that is large, that is called as ore. And if we are getting only iron oxide and removing all the gangue part from it, then what is it? We are getting concentration of the ore. There are different methods of concentration. Gravity separation method. Then there is a magnetic separation method. If the ore is iron, naturally iron will be attracted. There is a froth flotation method. Sulfide ore separation is done. Gravity separation method is done for those types of metals whose densities in which there is the metal density is high and the waste density is low. Okay, and there is a leaching method. Then after concentration, we have to do roasting and calcination. The main aim is that we have to bring all this ore, which either it is found in the sulfide form, carbonate form, any form, we have to convert that into oxide form. So roasting and calcination is mainly done for the sulfide ore. If the ore is sulfide, roasting is done because by heating, sulfur will get attached, will remove, and the oxygen will, the metal oxide is formed. Even the carbonates metals are there. Calcination means carbonate method. By doing this calcination method, what happens? The carbonate part will be removed, the CO2 will be removed, and what happens? The oxide form is removed. So we have to bring all the metals in the oxide form. If it is in sulfide form, metal sulfide, we have to convert it into metal oxide, that is roasting method. If it is a carbonate, metal carbonate, then we follow the calcination rule, and then it has to convert it into metal oxide. So main aim is to remove the metal oxide. So after the formation, and if the metal is found in metal oxide form only, then there is no need for roasting and calcination. So now you've got all the metals in metal oxide form. So the process of reduction is done. The process of reduction means removal of oxygen. And removal of oxygen from different metals is done by different process. If it is a least reactive metal, just heat alone. Heat it. What will happen? It will be removed. The medium order reaction, but is between carbon and hydrogen. Either you can remove by a more reactive metal like an aluminium. You can also remove by carbon, because as I told you, these metals come between C and H. So after C, they can be easily removed. Then there is a process that is called refining. Whatever metals that are found have to be refined to obtain a pure metal. The metals that are formed after reductions are not 100% pure. So we need metals that are 100% pure. Therefore, the process of refining is done. So let us study in details about all these topics that we have discussed now. Extraction of metals from the ores are mainly done in 3 steps. First is the concentration of the ore. See, concentration of the what we did. Separation methods are there. That is the gravity separation, magnetic separation, froth flotation, leaching process. Second is reduction of the metal. Reduction of the metal is done by all these processes. Reduction of metals for the metal oxides are done by heat for the more reactive metal, middle order reactivity by a more reactive metal, and by passing electric current to the most reactive metal. So, and last one is the refining process. Refining means the metal that is obtained after reduction is not pure, so we have to make a pure metal. Here the concentration of methods are there. This is a froth flotation method, mainly done for the sulfide ore. The sulfide ores are got low density. Whenever a compressed air is put inside this, there's a oil, there's a water. Inside the water, we have put oil and the sulfide ore is put. High pressure gases pass through it. Froth will be formed above, and the particles, the froth carries the sulfide particles. This can be easily removed and washed with water. All the clay particles, sand particles will settle down. This is a gank part, it will settle down. This is a magnetic separation. Here the ore that is rich in iron is allowed to pass through it, through this pulley. And what happens? The magnet will be attracted towards this and the non-magnetic particles will move apart. And this is a gravity separation method. It is mainly used for such type of such separation method is used for such type of metals whose density is very high. Just a powdered ore is put inside. What happens? Water is allowed to come. This metals being heavy will settle down, and it can be this concentrated ore, concentration of the ore. It will be removed, and the lighter particles will be removed from above. The lighter part, here this method is mainly used when the waste, that is the impurities, have got low densities. Since we have discussed and now we know very well the reactivity series, we are going to divide the metals into three parts: the high reactive metals, the middle order reactive metals, and the low reactive metals. The high reactive metals, that is above the carbon, the potassium, the sodium, the calcium, aluminium, those metals comes under high reactivity. They are so highly reactive that it is very difficult to remove oxygen from there, and therefore they are removed by the process of electrolysis, during which current is passed and oxygen is removed. The middle order reactivity, that is those metals that comes within the carbon and the hydrogen. Those metals are mainly found either in the carbonate forms or in the sulfide. So as I told you, we have to do either calcination process or the roasting process. They are heated, those metal ores are heated, and when they are heated, the carbonates are converted into oxides. The sulfide metals are going to be converted to oxides. So our main aim is to obtain metal oxides. When metal oxides are formed, like here it is middle order, you can go with zinc. Okay, so zinc oxide is there. So zinc oxide is obtained. Zinc sulfate was, ZNS was there. So it was heated. Roasting, you know how to make chapatis is called roasting. It is heated. S part is removed and O will attach to it. So ZNO, oxide of metal is formed. Now you have to remove oxygen. That process is called as reduction. Okay, so by doing that reduction, we'll get a metal. And the last step is obtaining a purest form of metal after a metal is formed. Now the low reactive metals, if they are found in sulfide or roasted, sulfide form, it has to be roasted to convert into directly metal. After roasting, an oxide is formed, and after oxide, just give little heat, oxygen is removed. So here low reactivity series, the process, just you have to heat, the sulfide ore will be converted into oxide, metal oxide, and the metal oxide can be converted, the oxygen can be easily removed by heating. Only by heating the metal oxide is also removed. Here the metal oxide is not removed by heating. In metal oxide, the oxygen is not, in metal oxide, the oxygen is not removed by heating. The oxygen has to be removed by a more reactive metal. I'll teach you that further. So low reactivity series, this mercury sulfide is formed. So just heat it, mercury oxide is formed. Just heat mercury oxide, you're getting mercury. Similar cases with copper. Copper is found in sulfide ore. What happens? Just heat it. Copper oxide is formed. Just heat the copper oxide, you'll get copper. So this is cinnabar. What is cinnabar? Mercury oxide. And the low reactivity series, they don't have tendency with oxygen much. Just heat it, the oxygen will be removed. This process is called as reduction. What is reduction? Removal of oxygen. Okay. Now, the metals in the middle reactivity are like the zinc, iron, and lead. They can be found either in oxide form directly, no, they can be found in sulfide or carbonate. If they are found in the sulfide and the carbonate form, they have to be converted into an oxide form. So either roasting or calcination is done. Roasting is done for sulfide ore and calcination is done for the carbonate ore. So here zinc sulfide is heated, zinc oxide is formed. Zinc carbonate is heated, it is converted in zinc oxide. So now you have got zinc oxide as a metal. The main aim is to obtain zinc oxide. Now we have to remove oxygen. Now here oxygen cannot be removed by heating like we did it in the least reactive metal. See here mercury oxide is just heated and oxygen is removed. This is in the least reactive metal. Just by heat oxygen is removed. But over here oxygen is not going to be removed by heating. So what we have to do? We have to take a more reactive metal or even carbon as a non-metal, which is more reactive than zinc. And what will happen? This coke will easily react with zinc oxide and we'll get a zinc metal. One is a thermite reaction. There are many reactive metals like sodium, calcium, aluminium, and they are used to as a reducing agent to obtain metals from the metal oxides. Let us take an example of aluminium. Aluminium is more reactive than manganese, and therefore it will displace the manganese, and we'll get manganese and aluminum oxides. The reaction between these metal oxides and aluminium is very exothermic, and the metals are therefore obtained in a molten state. Such a reaction is called as thermite reaction. It is used to join the rail tracks. So during the rail tracks, instead of manganese, you can take iron oxide. So aluminium can displace the iron, and what will happen? Aluminum oxide is formed, and it is, since it is a exothermic reaction, the metal that is obtained is in liquid state, iron is obtained in a liquid state, and what will happen? Easily the joints can be done. This is Fe2O3, aluminium, Al2,3 plus large amount. Other than that, it is also used to weld the broken machine parts. Here, the thermite welds that are going on. Extraction of metals from a more reactive metals, the metals that come above the carbon. Now, let us take NaCl in a solution. Take a 2 electrodes, one is a positive end and one is negative end. The positive end of the electrode that is connected to the positive side of the battery, it is called anode. The cathode is negative because it is connected to the negative end of the battery. And when the current is passed through it, what will happen? We'll get Na positive and Cl negative. The reaction occurs as Na positive will what happen? Accept an electron and become sodium, and Cl negative, it will give away electron and become Cl. So this is an extraction of metal like a sodium metal. The sodium metal is deposited at the cathode and the chlorine gas is obtained at the anode. You can see the reaction at cathode. Sodium is going to accept an electron and become sodium metal, and chlorine will give away 2 electrons and it will become chlorine 2. See, negative means it has got more electrons, so it has to give away electron. Positive means the electron number is less, so it is going to accept an electron. And that is how the sodium metal is obtained. The last step is called as the refining of metal. The metals that have been obtained from the most reactive metals, the least reactive, and the middle order reactive metals by different processes are not 100% pure. And we have to make up metals that is pure. It has got impurities. Sometimes that impurities are also very essential and very important metals also. See, the impurities are not that they are sand and clay. That has been removed from the ore. Here the impurities are different metals, and sometimes we get expensive metals also from them. So the removal impurities from metals to obtain the pure metal is called as the refining of metal. The most common method for refining of metal is electrolytic refining. So let us take an anode and a cathode. anode has to be an impure metal and cathode has to be a pure metal. And the electrolyte has to be a solution of the metal that has to be a salt solution of a metal that has to be purified. Let us take this impure copper, that is an anode on the positive side. This is on the positive side of the battery. The pure copper, that is on the cathode, that is on the negative side of the battery, therefore it is called cathode. And therefore the solution has to be copper sulfate. See, if it is aluminium, the solution has to be aluminium sulfate. So it should be the solution, salt solution should be that of the metal that has to be refined. Now, what happens over here when the current is passed? The pure copper will be removed from the impure copper and it will go and start depositing on the cathode. So the impurities will settle down and they are called as anodic mud. This is how you can see over here. This is an anode mud. This is a pure metal. This is a this is an impure metal. This is a pure metal, and this is impure is thick. This is thin. What happens? The copper is slowly and slowly going and started depositing on the cathode part, and slowly this impure metal is going to become thin because the copper is being removed from here and it is being settled down on the cathode. So this is the refining of metal. See again, impure copper anode, pure copper. That was in the starting position. Ending, what is happening? It has become thin because most of the copper is removed and it has gone and deposited on the cathode. So this way you're going to get a pure copper on the cathode side and all the impurities will settle down, and that is called as anodic mud. The next topic is a corrosion. It is a damage caused to the metals due to the reaction of metals with oxygen, moisture, carbon dioxide, etc. For example, the brown coating of rust over iron. You can see this iron was like this, but because of moisture, it has become rusted. A green coating of copper carbonate over copper. So this was initially copper. You can see green coating over here. That is because of formation of copper carbonate. Here also you can see green coating because it is a formation of copper carbonate. And the formation of black coating of silver sulfide over silver. Silver, you know the color of silver, and it has become black because it has got now coated with silver sulfide. An experiment to show that air and moisture are very much necessary for rusting. So we have studied about this rusting. So how do rusting take place? Rusting takes place because of moisture. So let us take test tubes. 1, 2, 3, mainly the 3 test tubes and a 4th test tube. Okay. Let us put nails in all this, iron nail. Now in this first test tube, we have kept calcium chloride, and calcium chloride means it will absorb moisture. Since it is covered, what will happen? This is a dry air now. This iron nail is not in contact with any moisture, only air, and that is dry. Let us take another test tube where we have boiled the water so that there is no oxygen in it now. We kept a layer of oil on it so that no exchange of air can take place, and we have kept it. So now here it is water, and this water is without any oxygen. And the last one, we have kept a nail in which the normal water, and it is exposed to both air, that is water both. And here again a normal salt solution that you found in the tap water. After 2 to 3 weeks, what will happen? No rust is formed over here. That is, dry air will not promote rusting. Here also no rust is there, means only water. It's not. You can see many ships that are found deep into the ocean, very deep. They're lying down. They're not rusted because no oxygen has reached to that level, and they are still the same. So water without oxygen. So for rusting, what is necessary? Both oxygen and moisture with water. That is moisture, we call it, oxygen and water. That is necessary for rusting. And even in the salt solution, rusting is done and very fast. So here is what we have learned, that in the first test tube, it is not rusted because it has got only air, no water. Second test tube, it was not rusted because it had only water and no air. And the third test tube, it got rusted because it had got air and water. So air and water means moisture is necessary for rusting. How to prevent the corrosion? You can apply oil or grease, but if there is any gardening instrument, you cannot put paint on it. So you can put oil or grease on such gardening instruments. You can apply the paint, like our window sills, they are painted by galvanization. So what is galvanization? Galvanization is making a coating of a more reactive metal above it. If it is iron, you can put a zinc on it. Zinc is more reactive. What will happen? Zinc will react with oxygen and a zinc oxide layer is formed and the inside layer is saved by tinning, that is coating with the tin. Then by electroplating, that is coating a less reactive metal like chromium. Even electroplating, you can see many of your vessels, they are plated down with copper. So that is copper plating. Many of the gold, silver metals, they are coated with gold. That is also called electroplating. So by electroplating, there is a expensive metal can be coated on a less expensive metals, or one that is easily do corrosion, so that it is saved and it can be used. And by alloying, that is mixture of two or more than two metals or metals with non-metal. So what is an alloy? Alloy is a homogeneous mixture of metals with other metal or a non-metal. Some of the alloys are steel, stainless steel, brass, bronze, solder, amalgam. Steel is a mixture of iron and carbon, that is a metal and non-metal. Stainless steel is a combination of iron, carbon, cobalt, and nickel. Brass is a combination of copper and zinc. Bronze is copper and tin. Solder is lead and tin. Amalgam is a type of alloy in which any one metal, when it is mixed with a mercury, it is called as amalgam. Thank you so much. See you in the next session.